All right, welcome. We are on day 2 of adding and subtracting polynomials, and we're going to add and subtract polynomials of degree 1 and degree 2. So what does it mean when we have degree 1 and degree 2? Well, remember from last time when we have the degree of a monomial, right? Basically, you are adding up all of the exponents of its variables. So you look at each of the variables, right? Here we have a 2, here we have a 4. And you say 2 plus 4 and you get 6, right? So that's a degree of 6. That's how that works. You just add up the exponents on top of the variable, okay? And but when it's a little bit different when we say the degree of a polynomial, right? The degree of a polynomial is where we compare. It's just the greatest. So you look at each monomial, right? You got degree of 0, a degree of 2, and here you have a degree of 1. And you're just like, okay, what's the biggest number? Well, the biggest number is 2. So this entire polynomial has a degree of 2. So when we say we're only going to be adding and subtracting polynomials of degree 1 and degree 2, that means that the exponents are going to be no larger than 2. Okay? It's kind of a way of saying that. All right, just so that you get familiar. Let's go ahead and let's pick up where we left off. I'm going to scroll all the way down. Ooh, I wanted to talk about, oh, yeah, a little refresher, guys. I'm going to scoot all the way down to the very, very bottom. And I want to write down, refresh my brain, like terms. You can tell me in the chat. You can yell it out, whatever you like. Like terms. Remember, what are they? So go ahead and type that in. But I also want to remember that we can only add or subtract if we have like terms. Okay, very good. Y'all are awesome. Okay, yeah, and if you don't remember, let's see, like terms are, hold on one second. Yes. Like terms, y'all are absolutely correct. Like terms have two things in common. They basically have the same variables with the same exponents. Okay, and that's basically it. Yeah. All right, let me go ahead and let people in. Alrighty, so keep that in mind because we're basically adding and subtracting, and we can only add and subtract if we have like terms, okay? Oh, I'm gonna go ahead and clear that. Are y'all okay with that? You're gonna write it down? Okay, hold on, let me pause. I'm gonna show y'all two different methods, okay? And the first one is the horizontal method, the second one's a vertical method, and you just kind of tell me which one you like, okay? With the horizontal method, this is kind of like if you're pretty quick with it, once you've got a hang of it, you're just like identifying like terms. So you have 7y squared. Which of the terms here is like?
5y squared.
The other one that has the y squared, right? Okay. So I'm going to go ahead and underline that once right there, like that. And then I'm going to go ahead and go to the next one. Got plus 2y. And so then that one is like with negative 4y, and don't forget to include the negative, right? And then I just like to circle my constants. Okay. And so when you do this, remember that when you add and subtract, you're basically just, and I'll make a little note, when you add monomials, just add the coefficients. Okay, add or subtract the coefficients. So do not change the variable or the exponent, okay? Don't change the exponent. And if you need me to write bigger, just let me know, okay? So when I do that, that's going to be, I'm just going to write it like this, 7y squared plus 5y squared. That's 12y squared, right? And when you get really good at it, you can just kind of skip that one step and you just know, oh, that's 12y squared, right? All right. Next one, got 2y minus 4y. And so that's just going to end up being plus, I got plus 2y minus 4y, and you got negative 2y, right? And then you have your negative 3 plus 2, and that's negative 1. At this time, am I assuming that you are pretty proficient with being able to add and subtract signed integers? Absolutely. Can you use your calculator and do this at your pace when you're doing it? Sure, absolutely. Okay. But I do encourage you to get really good at that. So that's the horizontal method. The vertical method is more where you stack them up. Now it's important that you write the first time you write it in standard form. And so we talked about that last time, what standard form is, right? You have a degree of 2 right here, a degree of 1, and a degree of 0. So you just make sure that they're going from greatest to least. And so you just write it like this. Okay, and I gotta tell you, most of my classes have been liking this vertical method. I think because it reminds them of maybe like when they were little and doing like nice, simple, easy math problems. They were little, a long time ago. So you take the 2, right? And you're gonna put it underneath the 3. Okay, because they're both constants, they're both like terms. The other thing I wanna point out is that you want to include any sign that's with it. So it's like whatever's before the parenthesis. Well, there's nothing there, so it's actually plus 2, right? And then the next one is negative 4y. So that's going to go right here. And then you got plus 5y squared. So that's going to go right here. And just double check. Okay, it's in the right order, right? And these are all like terms. And so 7 plus 5 is 12. 12y squared. And they got 2y minus 4y, negative 2y. And then negative 3 plus 2, negative 1. And there you go with this. That's your answer, okay? So in the chat, if you would, just tell me what method you like best. You can click H enter, V enter, whatever one you like, horizontal or vertical, and that will determine how we move forward with the remaining portion of this class. So let's go ahead and let's look at example 3B, okay? So again, here we're adding. We're gonna go ahead and stack this up. It's already like degree of 2, degree of 1, degree of 0, so it's already in standard form. 4x squared minus 2x plus 7. So if you're watching the video right now, it's a great time for you to pause, okay? For those of you who are with me, I want you to go ahead and set up this and begin to solve. And I'm going to catch up with you in about 30 seconds or so, okay? You got all the basic stuff right. Okay, so let's go ahead here and we're going to go ahead. We got 4 minus 7. And if you need to put it in the calculator, you can, you know, okay? But 4 minus 7 is negative 3. Negative 3x squared, because we always keep the sign of the larger number, right? Okay. Then you got negative 2 plus 3. Well, again, we're going to keep the sign of the larger number, so it's positive 1x, right? Okay. And then plus 7 minus 9, negative 2. Okay? Because again, we're keeping the sign of the larger number. That happens when you have different signs, right? You keep the sign of the larger number. And the only thing that you're not going to see on the test whenever like, if this is your answer, the way it's going to look on your exam is like this, negative 3x squared plus x minus 2. Because that 1 that's in front of x is just kind of assumed. That's your little ninja right there. Are there any questions? Okay. Let's go ahead. Let's try this again. Example 4a. Now this one is slightly different. And the main thing that is different here is that we have a subtraction sign. And so we are subtracting. So that's a big deal, okay? When we are subtracting, I'm gonna make a little note. With subtraction, I'm gonna write it over here. With subtraction, you must distribute negative, the negative 1 first. Okay. That has to happen first. So what do I mean by negative 1? Well, right there, that's like negative 1, right? And essentially, we're going to distribute that. Now keep in mind, there's no sign in between the parenthesis and the 9, right? And so that's really the same as saying -1 times positive 9y to the fourth. And all you're doing is you're like changing the sign. So it's like -9y to the fourth. That's the most common, like people want to change the sign and they make it positive. Well, it already started off positive and now you're going to make it negative. And this is -7y, so you're going to make it positive 7y. So it's -1 times -7. And here you have -1 times positive 2, which is -2y squared. Okay, see that? All right. So that is something you have to do first, number 1. Now we're going to take all of these options here and we're going to stack them up. Now keep in mind, this has a degree of 2, this has a degree of 4, and this has a degree of 1. So we are definitely going to have to write that in standard form, which means that we take the biggest one first, 8y to the fourth. Okay, now notice I don't have a 3. You know what you could totally do? You could put plus y plus 0y to the third to kind of hold that place, right? That's a 3. And then we have plus 6y squared, okay, because that's got the 2, and then we got the 1, -5y. Okay, I made it up. I just pulled it out of nowhere because I'm using it as a space holder, especially if I have a problem over here. Let's say it was like plus y to the third. Like, where would I put that, right? And so notice how it goes in order. It's like 4, 3, 2, and 1. Okay? Do you see the 3? It's an ugly. Where is it in the equation? It's not, but the reason I did it is because it's a placeholder. It like, so for example, I'll do like this really easy problem. Let's see if I can. The idea is that like, okay, let me scoot down here. I'll do it. Okay. What if I had something like this? I have x squared and I have I don't know, 2x to the third plus x squared plus 5. Okay. And I'm wanting to add, I want to add x squared plus 5x. Okay. So if you were doing this by putting in a little placeholder, because notice that we don't have a place where x is just, you know, to the power of 1. So I can put 0 times x to the power of 1 plus 5, right? So now I have a place to put x squared. That's going to go right here, right? And now I have a place to put the 5x. That's going to go plus here. And when I solve it, just bring this down. 2x to the third. 1 plus 1 is 2. And 0 plus 5 is 5. So it just kind of holds the spot. Do you see that? It doesn't really change any of the value because honestly, 0 times x is just 0. It goes away, right? But it does hold the spot. And when we're using the vertical method, it allows us to kind of hold a spot and put everything where it should go. Okay? So hopefully that helps a little bit. All right, let me go ahead and go back to the problem we were doing. And we're going to bring down this stuff. So I've got -9y to the fourth. That's going to go underneath the one where we have y to the fourth, right? Because they're like terms. And then I have plus 7y. So that's going to go at the end because these both have just y. And then I have -2y squared. So that's going to go right here. Okay. Now it turns out this one didn't have it. It's not going to really change anything. But it's a good habit to kind of get into. So we have 8 minus 9. Different signs. That's -1y to the fourth. This is plus 0y to the third. 6 minus 2 plus 4. And then we have -5 plus 7 plus 2 and y. So we're not going to see this on the exam. What we're probably going to see is the 1's going to go away. The 0 term zeroes out, right? And we are left with this. That's our final answer. Questions? And Alexis, yes, you were there like a while ago. Yeah, good job. Any questions? Okay. So now your turn. Okay, if you're watching the video, now's a great time for you to pause and attempt to do this one. We're going to do example 4B. Well, unless you really love the horizontal method. So don't forget, the first thing I need you to do is distribute the -1. Okay, distribute that -1. And I want you to put in the chat what you got. Okay, after you distribute the -1. Yeah, just that part. All right, guys. So for those of you who are writing, we're going to write this in standard form. We talked about we're going to take the largest degree first. So that's plus 11n to the 3rd power. I can do better. Hold on. Let me write that better. Okay. And so that's 11n to the 3rd power. That's plus 6n to the 2nd power because it's 2, right? And then we just put the last one, plus 2n. And then we're going to take all of these and then put them underneath there, right? And so let's go here. So this -4n, I'm going to go ahead and I'm going to ask, let's see. Javi, where am I going to write that? -4n, is it going to go in the first column, the second column, or the third? He says the second, and he's so close. It does have an n here, right? But it's got the power of 2. So this doesn't have it, right? You want to try again? What column do you think would be the best? The first, the second, we know it's not the second, or the third? The third. The third would be better because see how they both have just the ends, right? Good. Okay, yeah. All right, so Sophia, I'm going to ask you something. Where am I going to put the +3? First, the second, the third, or there's your hand. Okay, I'm asking you a trick question. Okay, you want to help her out, Alexa? Yes, you put it at the very end. It was none of the above, right? Because that's where your like degree 0 is, right? That's where your constants are at the very end. So we just tack that on at the end, right? Yeah. And then, so that was a trick question. Sorry about that. And then I'm going to go ahead and ask, let's see, Karen, where does the -5n squared go, sir? The first, the second, the third, or the fourth? Perfect. Wait. Oh, close to being perfect. Sorry, my eyeballs messed up. It's a 2. This has a 3. Yeah, second one's a better choice, right? -5n squared. And so basically, do you see how we stack them up? Make sure that you got the right one with the right partner, right? The right like terms, okay? Yes.
With the +3, would it just be like +0, and then at the beginning would it be +0 and to the 3rd power?
Yeah, if you wanted to. I mean, I don't really see a need to put a placeholder right here, but if you wanted to, absolutely. Or if you really like, you know what, I really want the 0 there, then you could put +0 as your placeholder there. Yeah, you could. Absolutely. And you could, if you wanted to put +0 and to the 3rd, you could do that. Okay, just to make sure I got everything all perfect. Yes. Okay. And so we've got 11n to the 3rd. That just drops right down. 6 minus 5. It's 1. 2 minus 4. -2. 0 plus 3. Plus 3. And notice that we're not changing our exponents or anything, right? What's the only thing that's going to be like you're not going to see on a test? Like as an option. What's the only thing that's a little different? Not wrong, but just a little different. The 1 before the n squared, right? They're not going to have that. They're probably going to write it like this. 11n to the 3rd power plus n to the 2nd minus 2n plus 3. And there we have that. Okay. All right. Today's a little long. I know. Thank you for your patience. We're going to do a word problem. I'll try and make it as painless as possible, okay? Any questions on subtracting? Okay. So let's take a look at example 5a. Now, there's some information that you need here, okay, that's not in the notes. And so, go away. Okay, there we go. So the first thing that we need to understand is like, what is R, what is T, what is all this stuff, okay? And so when we do this, let me see if I can find my little thing here. Nope, okay, I'll have to do it off of memory. I think I remember it. All right, so basically there's this toy store, right? And they have something called the, it's total sales, okay? And I believe that's what this was. This was the total sales. T is for total sales. And it's the sales of 2 different types of things. This store sells 2 things. They sell video games. And they sell traditional toys. That's like blocks and trains and stuff like that, right? Now this is total sales, so it's dollars and it's in billions. Big company. Okay. R is going to be the sales for traditional toys. And V is going to be the sales, which I'm sure my son is mostly responsible for video games. Okay. Now they give us this R is equal to all that good stuff, right? And then you got T, and that's equal to all of that, blah, right? But what we want to do is we want to write an equation that represents the sales of video games V. So just using V, R, T, maybe a little equal sign, maybe a little plus or minus, that type of thing, okay? I want you to write an equation for V that represents the sales of video games using R and T as well, okay? So I'm gonna put it on pause and record here. All right, I don't know about y'all, but I think, okay, total sales, I'm thinking T's gotta be like, it's always like the total's always on the right-hand side, right? That's your T, that's your total sales. And what makes up those 2 types of sales? Well, video games and traditional toys, right? So that's gonna be V for video games. And then I'm gonna add R for the traditional toys. Y'all with me? Okay, then we wanna get V all by itself, right? And so how am I gonna get V by itself? What do I need to move? The R, right? So I'm going to subtract R, and I'm going to subtract R. That will zero out, right? And that's how I get, and I probably should have written it like over here, but here we go. That's how we get V equals, because that zeroes out, T minus R. You with me? Yeah? Okay. So now it's going to get hairy, okay? Now we're going to go ahead and we're going to put in 2 things. We got the T, and we're going to subtract the R. Okay. So in the T, I'm going to put in everything that is T, right? All of this good stuff. And I was really hoping that when I did this problem that it would become magically beautiful and it would just kind of simplify. No, not really. Oh, goodness. Okay, I'm going to need more room because I can't write that small. And here we go. Plus 4.4n plus 22.6. And then we're going to subtract this. 0.46 n to the third minus 1.9 n to the second plus 3n plus 19. Yay. Okay. Now, I don't think it's not going to be that hard, hopefully. I think it's just going to be more what we call tedious, right? It's all these like little tiny little things you got to do, right? So what I'm going to do is I'm going to change all of my signs, and then I'm going to write it and I'm going to stack it underneath. Yes? So here's to changing all the signs. Negative 0.46 n to the third.
Wait, does it matter which order the numbers go?
Like,
can R go first, or does it have to be T?
It does have to be T.
Oh.
It's like 5 minus 3 is not the same as 3 minus 5.
Oh,
Yeah? Okay. So here I'm going to change my sign. 1.9 n squared. And then here you got negative 3n. And here you got negative 9, right? And I'm so going to be lazy. I'm not going to rewrite this. It's already in standard form. So I'm just going to like put a line. And I'm just going to say, okay, let's stack them. Negative 4.6 n to the third. Okay. Plus 1.9 n to the second. Minus 3n. Minus 19. And y'all check me if my math is wrong, because I'm going to do this with my brain. So this is going to be 45 cents minus 46 cents. That's like 1 penny. In negative, right? Okay. And man, if you're doing this on your phone, I feel for you. Okay. And then I got $1.90 minus $1.85. So that's going to be positive 5 cents. It just makes more sense to me if I think of it in terms of money. Yeah, keep the sign of the larger one, right? $4.40 minus $3, $1.40, right? And $22.60 minus 19, that's plus $3.06, 60 cents, right? There you go. So we got all of that beautifulness, okay, representing the sales of video, right? In dollars, in billions. Sales for video games in billions of dollars. Okay. Yeah, feel free to. They're your notes, right? So here's your lovely little equation. And then it says, use the equation to predict the amount of video games sales in year 2022. Now, the other thing I forgot to tell you was that N is equal to the number of years since 2010. I realize that's a long time ago for some of y'all. Okay. In the chat, I want you to tell me, what does N equal in 2022? No, it's okay. So yeah, you want to subtract, and basically we're going to subtract 2010. And I mean, all of that, you know, so you just get 22 minus 10 and you're looking at like 12. So yay, N is equal to 12, okay? So there's a lot of ways. You could definitely put it in your calculator, put parentheses. I'm going to show you one technique how to do it. This is just one way. And it works because N is a nice whole number. It's an integer, right? So I'm going to go to Y equals. I'm going to like clear all that junk out, whatever that was. And I'm going to type this god-awful stuff in there. So 0.01, and instead of N, the calculator likes X. So we're going to put X to the power of 3, right? Make sure you go to the right. And then you got plus 0.05 X to the second power. Go to the right. Okay. Plus 1.4 X plus 3.6. Did I tell y'all wouldn't need the calculator? Sorry about that. I was just thinking about that. Sorry, because nobody, yeah, that would be very, like, a lot of time to do this in your head. But you get the idea, right? You put the whole thing in there, and you can actually go to your table, second table, and there's your X value, otherwise known as N. And you look for 12, and guess what? There it is, right? Let me make sure that I entered the equation right, because something's not feeling quite right. 0.1, did I do all my math right? I'm thinking, Yes.
Well, that was supposed to be negative 0.1.
Yes, thank you. I was like, something's not quite right. Something's like, okay, negative. Thank you. So it's always good to double check that you didn't like, because it's so easy to make a mistake on the calculator, right? And then like 1.4 and then 3.6. Okay, and now I'm going to hit table. Now I'm going to look for where x is equal to 12. So that's 12 years later, right? And it's 10.32. Okay. And so what that means is that in 2022, video game sales should be, we're going to estimate it, right? Should be $10.32 billion. Not bad. And ladies and gentlemen, that's how you do that. Okay? I know that was a long one. We probably will have at least one day this week where we can kind of catch up. Okay? All right. Y'all have a beautiful day. Take care. I hope to see you tomorrow. Bye.
Bye.
Bye. She always has so much energy.